In this video, we are going to solve equations with rational exponents. Now, by rational exponents, we're talking about exponents that look like fractions. Now, let's quickly review these steps. You can refer back to them later, but first, when we're solving equations containing rational exponents, we're going to isolate the expression with the rational exponent, so get it by itself, and then we're going to raise both sides of the equation to the reciprocal power of that rational exponent. Now, there's a couple of complications. We won't need to worry about the first one with the examples I've chosen, but just to make sure you're aware of it, if the numerator of the reciprocal power is an even number, the solution must be checked because the solution involves the squaring process, which can introduce extraneous roots or solutions that aren't really solutions. Now, in one of the problems, we'll be encountering this issue. If the denominator of the reciprocal power is an even number, the denominator of the reciprocal. If that's an even number, this is equivalent to taking an even root. So we're going to end up with possibly two solutions. So we'll take a look at that a little bit later. And then once you've raised both sides to the reciprocal power, we solve the remaining equation. All right. That was all quite a bit to think about there. Let's dive in and just see how this works. Here we have c to the 3/2 power equals 2. Now we already have the term with the rational exponent isolated. That's already by itself. So the next thing to do is to raise both sides to the power of the reciprocal. So we're going to raise both sides to the power of 2/3. Now what that does is, since when we raise an exponent to an exponent, we end up multiplying. Well, that means we can cancel out this 2, and we can cancel out the 3's, leaving us with c all by itself on the left. Right, so we have 2 to the 2/3 power. Now, just to review, we could think of it this way, where we have the third root, that's the denominator, of 2 squared, or in other words, the third root of 4. However, since we are going to be answering this as a decimal, let's go ahead and work out 2 to the 2/3 power on our calculator. So I have 2 raised to the power of 2/3. Right, and that rounding to the nearest hundredths place, that's 2 decimal places. We look at the number after the 8 to see if we need to round up. We do need to round up, so 1.59. Okay, here's another one similar to that. We already have the term with the fractional exponent isolated, so let's go ahead and raise that to the reciprocal. And remember, the reason why we're doing that is so we can cancel out the exponents on the left side. So these 3's cancel, and those 5's cancel, because when we raise an exponent to an exponent, we multiply, leaving us with m equals 7 to the 5/3 power. Which equals about 25.62. So here we already have our term being raised to the rational exponent isolated or by itself. So we'll go ahead and raise both sides to the power of the reciprocal. So we'll raise this to the power of 3/5 and raise this to the power of 3/5. All right, those 5's cancel and these 3 cancels because 5/3 times 3/5 is just 1, leaving us with z minus 5 on the left. Let's go ahead and figure out 3,125 to the 3/5 power. And that equals 125. But that's not what z equals, so let's add 5 to both sides. To get 130. Similar situation over here. We already have the term raised to the rational exponent isolated. So let's raise both sides to the power of the reciprocal. So that those 5's cancel and these 2's cancel. We'll go to our calculator to figure out 1024 to the 2/5 power. (16). Add 3 to both sides to get c all by itself, which equals 19. Here we do not have our term being raised to the rational exponent isolated. We need to subtract 19 from both sides so that that term with the a is isolated all by itself. Now the term with the rational exponent is isolated, so we will go ahead and raise both sides to the power of the reciprocal. That leaves us with just a. And now we'll go to our calculator to figure out 7 to the 2/5 power. 2.18. First, we need to isolate the term with the m. So we'll subtract 15 from both sides. And we need to raise both sides to the power of 2/3. So m equals 8 to the 2/3 power. Now we could do this one on our calculator, but 8 is actually a perfect third root, or a perfect cube root. So just for fun here, let's go ahead and work this out with our roots. The third root of 8 equals 2, because 2 times 2 times 2 equals 8. Now, by the way, this 2 right here, that came from right there. So 8 to the 2/3 power is the same as the third root of 8 squared. The third root of 8 is 2, and 2 squared equals 4. So m equals 4. Let's take a moment to revisit our steps. We've been kind of ignoring these two technicalities so far because I purposely chose problems where these complications didn't come up or were not relevant. But let's revisit them right now. So if the numerator of the reciprocal power is an even number, then we have to check our answers. Checking our answers is always a good idea, but in some situations, like this situation, we really have to check those answers because the math might have given us a solution that is not actually a solution. It might have given us an extraneous solution. So that's if the numerator of the reciprocal power is an even number. Now, if the denominator of the reciprocal power is an even number, then we potentially end up with two answers. So here we have our term being raised to the rational exponent all by itself. It's isolated. We'll raise both sides to the power of 5/4. And we notice that our denominator of the reciprocal power, that 4, is an even number. Now in that situation, we're going to end up with two paths to potentially two solutions. Let's see, so those 4's cancel, these 5's cancel, leaving us with a minus 7 on the left. Now we need to figure out 625 to the 5/4 power, and we're going to have the positive version of that and the negative version of that. because the denominator of our reciprocal power is even. All right, let's go to our calculator, find 625 to the 5/4 power. We get 3,125. All right, so now we're going to break this up into two tracks. We have a minus 7 equals positive 300, pardon me, a minus 7 equals positive 3,125, and a minus 7 equals negative 3,125. So now we have two equations, and that's because our denominator to our reciprocal power was even. So this technicality comes up in that case. So we add 7 there and we get 3,132. Add 7 to both sides here, and we get a equals negative 3,118. All right, so we have two answers there, and let's just take a look to see why we needed this second answer here. Well, we notice if we substitute negative 3,118 in for a here, and then subtract 7, we get negative 3,125. But with this 4 up here, that positive 4, when we raise negative 3,125 to the 4th power, it becomes positive. And then when we take the 5th root, we get 625. All right, so since we're just barely learning about this, I didn't want to overemphasize this too much, but it's important that we get a little taste of this. Again, this one, we already have the term we needed isolated all by itself, so let's raise both sides to the power of 2/3. And that cancels out the exponent on the left side. Now let's see, we can quickly figure this out without a calculator because 125 is a perfect cube root, and we don't want to forget to square it. 5 times 5 times 5 equals 125, so the third root of 125 is 5, but then we need to square it. Now notice we didn't need to do the two tracks here. We had to do the two tracks here because the denominator of the reciprocal was an even number. Well, over here, it's the numerator that's an even number. And what that means is that we should check our answer to make sure it really is a solution. Make sure we didn't end up with an extraneous solution. Now, in this case, it's probably going to be fine, but we'll double check here. If this 125 had been a negative number, we might have had a little bit more to worry about, but it wasn't. So 16 plus 9, that's 25. That 2 there means take the square root, and the square root of 25 is 5. And we raise that to the 3rd power and get 125. So in other words, 25 to the 3/2 power, just getting that from up here, 16 plus 9. That does equal 125 because we take the square root of 25 and raise it to the 3rd power, which would be 5 to the 3rd power, or 125. I hope these examples about solving equations with rational exponents have been helpful. This is Mr. Ela, signing off.